Welcome to Challenging GCSE Maths Questions with Mr. Wesley. Every day, we take on one mind-boggling GCSE maths question designed to stretch your brain and push your skills to the next level. Mr. Wesley will break it down step by step so you can confidently ace those tricky final questions on your exam. Grab your notebook, your pen, and your calculator. Let's get solving. Oh, and before we dive in, make sure you hit that like button and subscribe. If you have any challenging questions you would like Mr. Wesley to solve in the upcoming videos, please email him the question. His email address is in the description. All right, let's do this. Here's Mr. Wesley.
Okay, this question is on circle theorems. So, a circle touches the sides of a triangle ABC at points P, Q, and R, as shown below. So there are three tangents to the circle, as you can see. They've called this angle X, this angle Y. Okay, and the first part is to show that angle PRQ, which is this angle, is x plus y over 2. And then the second part is to show that this angle here, RQP, is 90 minus x over 2. Now, before we do these two questions, I would like to remind you of two circle theorems. The first one is when you have a circle and from an external point you draw two tangents, the theorem says that the distance from the external point to the touching point is the same for both tangents. In other words, if this is O and this is A and B, OA equals OB. Now that's going to become very useful here, because from this external point A we drew two tangents, so this is equal to this, similarly this is equal to this, and this is equal to this. Okay, so that's the first circle theorem to keep in mind. And the second one is called an alternate segment theorem. That is, when you have a circle and a tangent, and then you have a chord here like that, and let's say you make a triangle, the angle on this side of the chord is equal to the angle on the alternate segment. Okay, now we are going to make use of that also. So the first part is to show that angle PRQ, this angle, is x plus y divided by 2. So let's try to do that. I'm going to erase everything and start from scratch. So, if this angle is x, because this is equal to this, so BR is equal to BP, we can find this angle, because we have an isosceles triangle. This side is equal to this side, therefore this angle is equal to this angle. So the size of that angle is going to be 180 take away x divided by 2. So 180 take away x divided by 2. Okay, and similarly this angle here because this is equal to this. This becomes another isosceles triangle. Therefore, similarly, that angle is 180 minus y over 2. So let's take this straight line. Remember, this is the angle that we are after. I'm just going to call that z. So we have 180 minus x divided by 2, and then other 180 minus y divided by 2. Add these two and z should give us 180 degrees because those three angles are in a straight line. So let's simplify this. This is 90 minus x over 2. This is 90 minus y over 2 plus z is 180. So this 90 and this 90 will add up to 180. There's 180 on the other side also. So if you imagine taking away 180 from both sides, all these numbers will disappear. So what we will be left with is the following. I want to write z at the front, then minus x over 2 minus y over 2 equals 0. Okay. Therefore, z is equal to x over 2 plus y over 2. Imagine adding x plus 2 plus y plus 2 on both sides. Now, let's take 2 as a common denominator. Z is x plus y over 2 as required. That is the first part that we needed to show. This angle Z is x plus y over 2. Okay, now I'm going to erase all this and we're going to go to part 2. Which is to show that this angle is 90 minus x over 2. But incidentally, this angle that we are after, which I'm going to call small p, is equal to this angle because of the alternate segment theorem. So if we show that this angle P is 90 minus x over 2, game over, because this angle is equal to RQP. In the previous part, we have already shown anyway that these two are equal, and therefore this angle is 180 take away x divided by 2, which is 90 minus x over 2. So just to make our steps clearer, I'm going to call this angle Q. So Q is 90 minus x over 2, but Q is equal to P because of alternate segment theorem. Therefore, P is 90 minus x over 2. Okay, I hope you like this question, and I will see you again soon.
Great job today, everyone. Remember, the key is to take your time and practice the questions regularly. If you found this video helpful, please like, comment, and subscribe. It really motivates Mr. Wesley to create more videos. If you have any questions, Feel free to email Mr. Wesley at WesleyMathsTutor@gmail.com. See you in the next one.